Welcome to Algebra 1, Section 3.8 and Algebra 2, Section 1.6 video notes. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. If you remember, ordered pairs are points. A scatter plot can show a trend or correlation which may be either positive or negative. Or the scatter plot may show no trend or correlation. It is often easier to determine whether there is a correlation by looking at a scatter plot than it is to determine by looking at the numerical data. If the points on a scatter plot generally slope up to the right, the two sets of data have a positive correlation. If the points on a scatter plot generally slope down to the right, the two sets of data have a negative correlation. If the points on a scatter plot do not seem to generally rise or fall in the same direction, the two sets of data have no correlation. Which is dependent on which in this situation? Is a girl's height dependent on her age, or is a girl's age dependent on her height? Well, hopefully a girl's height is dependent on age. So looking at the graph, the x-axis contains the independent value, which is the age in years, and the y-axis contains the dependent value, which is the height. In inches. So what we're going to do is graph this data. So I've already graphed it here in the table. Here in the coordinate plane. And so I treated the data as ordered pairs. Again, ordered pairs are points. So the average height of a 2-year-old girl is 34 inches from our table. So one ordered pair is 234. And I plotted this point right here. So if you recall, when you've plotted points in the past, you always start at the origin and you move over for your x coordinate and up for your y coordinate, and that's where you put your point. So we plot the other points, 337, 440, and so on. Notice that the height increases as the age increases. So there is a positive correlation for this data. A trend line is a line on a scatter plot that is drawn near the point. You can use a trend line to estimate and predict other values. So what we're going to do here on the back is draw a trend line for the scatter plot in our previous problem. So we have the graph drawn again here, and we're going to find an equation for the trend line, and then we're going to estimate and predict the average height of a girl who is 12 years old. So to create a trend line, you're going to use a ruler and draw a line that follows the path of the data. So an example of a trend line would not be this line that I just drew. Why? Because it does not follow the path of the data. The data points are going up and to the right, but the line that I just drew has a much sharper, higher slope than the path of the points. So I'm going to get rid of that, and let's draw this trend line instead. It's following the path of our points pretty closely. So this trend line goes to the points approximately 440 here and 850 here. Now, not all trend lines have to pass through the original data points. Sometimes they do, sometimes they don't. It just depends on the data that you have. In class, we're going to use the TI-inspired calculator to find the regression equation, but I do have some results for you right here in the table. The equation is written in, and here's our equation. Oops, wrong one. Our equation right here is written in slope-intercept form, which is f of x equals mx plus b, where f of x represents y, which is the height in this equation, our dependent value, and m represents the slope. Now you might see the term rate of change, and so it's good to know that rate of change is the same as slope with our graphs. The b value in the table represents the y-intercept, or the place where the graph crosses the y or the height axis. The r value in the table represents the correlation coefficient. Which shows how closely the equation matches the data. So looking at our table, we have our r value, as I mentioned, right here. We have the r squared also, which we're not going to deal with in Algebra 1 or Algebra 2. Our y-intercept is b. Our slope is right there. So that's our rate of change value. And so the calculator is just going to give you a general slope-intercept form equation, and then the specific values that would be substituted in for b, and then the correlation coefficient. So an r value that is close to positive 1 shows that there is a strong positive correlation to the data. An r value that is close to 0 shows that there is no correlation in the data. And an r value that is close to negative 1 shows that there is a strong negative correlation in the data. So the r value in our table shows that there is a strong positive correlation in our data. And I know that because this value is really, really close to positive 1. So that means with this close to 1 value for r, that the height seems to be a function of the girls' ages that are represented in this particular situation. So what we're going to do is use this equation to predict and estimate the average height of 12-year-old girls. So the equation in the table again, the regression REG equation, that is f of x equals mx plus b. So from the table, the m value is 2.51667. The x value from our table and from our graph is the age in years. So the age that we're trying to, the height that we're trying to predict is for a 12-year-old girl. So our x value will be 12. The b value is 29.567. 0.767. So again, these decimals that are given in the table above, those we will talk about in class as far as how to use the calculator to give you those values. So what we're going to do now, multiply and add. A calculator comes in handy here too, but I'll just tell you that will give us 59.7667. And since the problem did say predict and estimate the average height, then I can say the height is approximately 60 inches. This was a word problem. Therefore, I need to have words in my answer. Now, another thing that we could have done is we could have looked at our graph and just estimated from the graph what the average height of a 12-year-old girl would be. So looking at our graph, we have the age of a 12-year-old girl right here. Again, pick the wrong pen. There we go. There's the 12-year-old girl's height. And since I did extend my trend line so that I would have an x coordinate of 12, if I look up here on the graph, I have a corresponding y coordinate of 60. So that's another way that you could estimate your value. Well, we'll talk more about trend lines and scatter plots in class. So I hope you have a good night.